The way we normally introduce magnetic fields is with one of these, is with a bar magnet. So usually you draw it as a rectangle, although it's usually a cylinder in 3 dimensions. And we have put an N up here and an S down there. That's the North Pole and the South Pole. The fields coming out of a bar magnet kind of look like this, with the field lines emanating from the north and curving around to the south. And then this one kind of does like that also. And they're going in all 3 dimensions, some kind of like that. And I'm not going to give you the equation that makes that field. Like I said, this is not as straightforward as the electric field, where we just have the equation Coulomb's law giving us a field around a point charge. This is more complicated because it has to do with what's happening inside this material, which we're going to slowly figure out. Bar magnets were of great interest in ancient times because the natural materials that did this would always point north if you float one of these on water or if you hung it from a wire. And the reason is they feel a force that makes them align with the Earth's magnetic field. Okay, so if I draw the Earth here, all right, and if I draw some of the important structures of the Earth, like this, there, that's the Earth. This is the North Pole, and this is the South Pole. So Santa Claus lives here and the penguins live down here, okay? Now, we know then that the Earth has its own magnetic field where the field points basically this way. It points from south to north. Okay? So this is why if you take a bar magnet like this or any magnet with a north and south pole, it'll align to where it points north. The North Pole points north. So that's why we call this north and south, right? That's the historical reason that it got that name. If you look at this, you might quickly see something a little bit confusing. If the field is going that way outside the Earth, it seems like the names of north and south are wrong, right? Because the field lines are supposed to go from on the outside of the magnet, they're supposed to go from the North Pole to the South Pole. And here I have them going from south to north. And then you may have heard of magnetic north. Now, magnetic north just means the field lines are actually a little bit crooked. Magnetic north is like over here somewhere. But that doesn't solve the problem, right? It's still, they're going the wrong way. And the reality is the Earth is upside down. Magnetically speaking, freshman physics speaking, the Earth's, if we consider this same geometry of the Earth, the North Pole of the magnet inside the Earth is at the South Pole, is at the bottom. The magnet's upside down, such that when it makes field lines outside, they point north. Okay? So when you think about this bar magnet aligning with the Earth's field, it really is aligning with a magnet inside the Earth, and then you also see that magnets like to anti-align. They like to get the north with the south and the south with the north. If I were to align this little magnet with this bar magnet I drew and this were north, it would want to do this because it wants to align with this magnet's external field. And if this one, it's aligned with this magnet's external field. See, this one is going like that. Okay, so that's how 2 magnets interact. So, as you can see, there's no equations here. So next, let's see if we can chop this thing up and get down to something where we could write an equation. So I've told you about the magnetic field lines around magnets and around the Earth. Many things have magnets in them and have magnetic field lines. One is this. You may have seen these little magnetic bracelets before, and it's a little silver band with gold balls, but if you look right on the inside edge of the balls here, there's 2 little magnets embedded inside. So let's think about what those magnets are doing. So it looks something like here's a ball and the thing goes around, and here's another ball. It's very pretty. And the magnets are more or less here and here. And if they're smart, they put them like that, north-south, south-north. Therefore, you have magnetic field lines that kind of go like this, okay? Created by this magnet. A little field extends from one ball to the other. Now, when you put this on your arm, like this, they're against your arm, like that. So it's creating the magnetic field inside your arm. So here's your arm in cross section. There's your bones, radius and your ulna, I think, a bunch of blood vessels. And this magnetic field inside your body is doing absolutely nothing. Okay? They sell this as a remedy to treat pain and all kinds of conditions. It does nothing. This little magnetic field in your arm, in your body, has never been proven scientifically to do anything. And the people that sell this should be ashamed of themselves that they sell this on the public, the gullible public, to think that these magnetic fields are going to do anything. If it makes you feel better through some placebo effect, that's wonderful. Let it make you feel better because it's pretty. It makes you feel pretty to wear it. But don't believe that the magnetic field is actually doing anything to your arm.